All right, folks, let's move on to our next set of notes. So far, we've gone over molar ratios, how we get them from balanced chemical equations and write them in the correct format. And we did mole to mole conversions. So now we need to move on between mole to mass conversions. So back and forth between the two. So this is kind of taking it to the next step. At its heart, all of these problems that we're going to work on are mole to mole equations or mole to mole conversions. That's the heart of it. That's what stoichiometry is all about, is it's converting from moles of one thing, of one chemical species, to moles of another in the same chemical equation. So let's take a look at this next problem and we'll see how we solve it. So, excuse me. Whew. I don't find this boring. I'm just tired. All right. So how many grams of potassium sulfate will be produced from 63.01 moles of potassium phosphate? So let's hop right into this one. So just looking at the problem, we can tell that we are looking for grams of potassium sulfate. So potassium sulfate is right here in the equation, and that's what we're going to be looking for, is grams of potassium sulfate. And we are starting with moles of potassium phosphate. So when I look at this problem is a little bit more complicated than the previous ones, because we're going from moles of this reactant to grams of this product. Unlike the other problems that we've worked on, whether it's converting between grams and moles of a specific compound using molar mass, or whether it's converting from moles of one chemical species to moles of another in a chemical equation using molar ratios, there's not just one, there's no one equality that's going to do this. So we're going to have to use more than one equality. So this is going to take more than one step. This is where the skeleton method really shines, and this is where you can see how useful and how effective it really is. So we're going to have to plan this out a little bit. The first thing that I think of when I see this is that I know if I am in moles of a compound, I can always convert to moles of something else in that same equation. So our problem here is starting off with moles of potassium phosphate, and we need to get it into grams of potassium sulfate. Well, I don't exactly know how to do that directly, but I do know that I can get, if I have moles of potassium phosphate, I can get moles of potassium sulfate. So that seems like a good first step. So let's kind of set that up. Actually, I'll explain the whole process, then we'll set the whole thing up. Once I have moles of potassium sulfate, I can convert it to grams pretty easily using molar mass. So in this particular case, I'm going to need two different equalities. I am going to need the molar mass of potassium sulfate and the molar ratio of potassium phosphate to potassium sulfate. So I think off to the side, I'm just going to kind of jot these down. So I'm going to need a molar ratio. The molar ratio in this case is going to be something along the lines of, let's see, 2 moles of K3PO4 for every 3 moles of K2SO4. Okay. And I'm also going to need the molar mass. In this case, the molar mass of K2SO4, because that's the thing I'm trying to find moles of. So, or find grams of, pardon me. I already did the math on this one, but you could totally do it. It looks like it's 174.26 grams of K2SO4 for every 1 mole of K2SO4. Okay, so these are our puzzle pieces. And what our end goal is the same like any other skeleton. We're going to start with the information given to us in the problem. And we need to cancel out all of the units we don't want and end up with the units that we do want. So our first step here is we can't really use this molar mass because it only deals with potassium sulfate. So we're going to have to use this one because it actually has potassium phosphate as one of the units. So I'm going to end up flipping it upside down so that my K3PO4 is on the bottom. Okay. So this step right here, let me grab another marker. This right here is the molar ratio. And this is converting, this whole step here also is converting from moles of K3PO4 to moles of K2SO4. So that's what that step accomplishes. And we can see that the units will cancel right here, the moles of K3PO4. So there we go. Et voila. All right. However, anytime you're working on problems like this, we can always ask ourselves, am I done? Is this problem solved? And in this particular case, in any problem like this, we know we're done when we have the correct units. Right now, we do not have the correct units. We are looking for grams of potassium sulfate. We have moles of potassium sulfate. So we need to keep going. The next step is moles of potassium sulfate to grams of potassium sulfate. Well, I think we're going to use our molar mass right here. Okay. So this step, this is our molar mass. That's the name of this equality. And in this step here, we are going from moles of K2SO4 to grams of K2SO4. And once we've gotten that far, the only thing left to do is to do the math and just double check our units. So here we've got moles of K2SO4 and it's on the bottom as well, so those will cancel. So it looks like mathematically we just need to do 63.01 times 3 divided by 2 times 174.26. And that's a very, very, very big number. Let me see if I believe that. Hold on. I got a number that's a little bit unbelievable. Let me try again. I think I made a mistake. I got like 12,000. I was like, ooh, that seems a little high. 174.26 times 63.01 divided by 2 times 3. Now 16,000 seems to be correct. And let me just double check that one more time just to be sure. 63 times, yeah. Well, you know what? Now that I think about it, 63 is a lot of moles. So that does actually make a lot of sense. Okay, sorry. Let me do the math one more time. So it's always good to be skeptical of your numbers, but as long as the logic works and as long as the math is correct, you're good. But it's never a bad idea to just double check. Okay, so it looks like our answer to this question, it's not a lot of space to write it. I'll write it off to the side here instead. The answer is 16740 grams of potassium sulfate. And that is our answer. Okay. So this is the kinds of problems that just take a little bit of time to get used to and understanding this method. Well, if you follow the method, you can continuously add on more and more steps until it's done. I like this method because it keeps you really organized and it makes the math, it makes it so that you do the math as the last step instead of doing math along the way. There are other ways to solve these kinds of problems, but this is the way that I like to do it. Once again, the hardest part now is figuring out what are the steps. The key is this molar ratios. The molar ratios, think of that as always at the center. Every one of these problems, as soon as you have a balanced chemical reaction, everything comes down to molar ratios. You got to get things into moles. So we had to have potassium phosphate in moles, and it was given to us in moles, so that's great. And we could only find moles of potassium sulfate. To get to grams, we just have to do that extra step of molar mass. But again, the molar ratio is the important part. Okay. I think more practice will help, so let's try another problem. Maybe I won't annotate it quite so heavily. So how many moles of magnesium sulfate are needed to produce, hold on just 1 second. Oh no, we're good. Okay, perfect. Okay, how many moles of magnesium sulfate? Okay, so I'm gonna immediately are needed to produce 1.64 grams of potassium sulfate. All right, so we're back to potassium sulfate. That's great. So potassium sulfate again is here, up here in the equation, and we're going backwards. We're trying to figure out how many moles of magnesium sulfate we would need to start with. So once again, let's set up our equation or our skeleton, pardon me. Okay, 1.964 grams of potassium sulfate. Okay, we need to convert this into moles of magnesium sulfate. So we're trying to go from one chemical species to another. Anytime we see that happening, we know we need to have both of them in moles in order to do that. So they need to be comparing numbers as opposed to comparing mass. Currently, potassium sulfate is in mass. So this is not going to work yet. We're not able to use a molar ratio quite yet. So our next step should be to convert grams into moles. So once again, I have the molar mass of potassium sulfate right here. So let's just use that. This time we are dividing because we're converting from grams to moles. Okay. So converting to moles is usually a good idea, almost always. So we've gotten rid of grams and now we're in moles. So this step was converting grams to moles for potassium sulfate based on what the problem gave us. Okay, are we done? Well, the question is asking for moles of magnesium sulfate. We currently have moles of potassium sulfate, so no, we are not done. So now this is a good time for a molar ratio. So anytime we need to, again, convert from moles to moles, we're going to need a molar ratio. And again, the molar ratio is very specific to this equation. If we had a different equation, these numbers would be completely different. But we have this balanced chemical equation, so that's great. So it looks like we need 3 moles of magnesium sulfate for every 3 moles of potassium sulfate. Seems to be the ratio based on that. Now, this is actually a 1-to-1 ratio because 3 to 3 is the same as 1 to 1. So from a mathematical perspective, this step is not important. It's useless. It's kind of useless. But from a chemistry and conceptual perspective, this is the most important step. This is the step that allows us to use this equation to convert between different chemical species. Now, are we done? Well, yeah, I drew an equal sign, so we know we're done. But are we really done? Yes, because our units over here are going to cancel out. I'm just going to cross out those 3's. Those moles of potassium sulfate cancel out. And we're left with moles of magnesium sulfate, which is exactly what our question is asking us. So we are done. We are ready to go. Now we just have to do the math. So it looks like we're just going to need to take 1.94 or 64, pardon me, and divide that by 174.26. And we are going to get 0.011 moles of magnesium sulfate, and that's our answer. This is a pretty small number, but that makes sense because you're taking a number that's like 1 or 2 and dividing it by like almost 200. So it's going to be a pretty small number. And that makes sense because moles are a lot, and we didn't start with that many grams, so kind of makes sense. It's definitely less than a mole of potassium sulfate, for sure. In fact, it's less than 0.1 moles of potassium sulfate, and less than 0.1 moles of magnesium sulfate. Because again, it's a 1-to-1 molar ratio. However many moles of potassium sulfate, that's how many moles of magnesium sulfate you would need. Okay, so this is a good thing to start practicing. So let's take a look at that. At this point, oh no, the lights went out. I'm doing the weird turn the lights back on dance. It's not working. There we go. Okay, for these problems, let's go to the packet. So far, you've been able to do page 1, and you also were able to do page 2. So now it's time to move on to page 3. So page 3, let's see what we've got here. Oh, the bell's going off, crazy. All right. All right, so look at these problems. Let's read through them and we'll see if we can find one. This one looks like it's asking for moles from moles, so that we already know how to do that. Let's see, moles to moles, already know how to do that. Moles to moles, we can do that. Moles, moles, nope, that looks good. Moles, 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 moles. Okay, no, I think you guys can all do page 3. All right, rock on. So that's more practice that you can work on. I'll have an answer key for that at some point. Okay, here we go. So let's go to page 4. So we'll pick out the problem. Now, you'll notice that page 4 is really interesting. And page 3, they have the answers on the bottom, but they're for the reverse page. So the answer for number 5 is on the opposite side. The answer for number 1, it's on the opposite side. So anyway, they're all there, which is kind of cool. Doesn't have it worked out, but you know, that's all right. So let's do this. Excuse me. All right. So let's look at number 5. We have a chemical reaction here. First question is this balanced? And I would say, heck no, it's not. So let's do that first. Again, I just balance things in my head at this point. So there we go. Okay. So for the first question is, how many moles of aluminum oxide, so that's the aluminum oxide, will be formed from 12.1 grams of oxygen? Okay. So let's set up this problem. We are starting with 12.1 grams of oxygen. It's a good place to start. And remember, oxygen is O2 because it says so right there. Also, it's a Hofbrinkel. Okay. We are trying to get to moles of aluminum oxide. So grams of oxygen is not going to help us. We have to get to moles of oxygen. Once we have moles of oxygen, we should be able to convert pretty easily. So we're going to need the molar mass of oxygen, which is 32 grams of oxygen for every 1 mole. How do I know that? Well, I memorized that the molar mass of oxygen is 16. There's 2 of them. 16 times 2 is 32. Crazy. Okay. So if we do this, we now have grams canceling out, grams of oxygen. We are now moles of oxygen, and we can use our molar ratio. Our molar ratio in this case is for every, let's see, every 2 moles of aluminum oxide requires 3 moles of oxygen. So that will cancel out our moles of oxygen. And now we just have to solve and do the math, which is going to be 12.1 divided by 32 times 2 divided by 3. So it's not going to be a very big number. And in fact, it is 0.25 moles of aluminum oxide. Let's double check. Yep, that's the correct answer. So good. Slightly different number of decimal places, but who cares? Doesn't matter. Okay. So that's pretty much the whole idea there. I'm going to go back and I will give you more of an answer key here. But yeah, there it all is. Not too bad. This is very badly labeled. That's supposed to be B, by the way. Same thing here. Had some typing issues, obviously. All right, so I think we're going to just need a lot more practice with that, and I will be happy to provide you all with more resources for that and support. But that's a good place for you all to work at the moment. If I have any interesting YouTube videos that are helpful, I will post them in Teams as well. So let's stop there, and we will continue on with mass to mass conversions next.